Hi, I'm Ben Vigoda. I want you to imagine a new superpower. Imagine if you could have a conversation like you'd have with your friends, but with 1,000 people simultaneously, or even 1,000,000 people. Not just twittering or something, but actually having a personalized conversation simultaneously with 1,000,000 people. So that was already a dream or a challenge when I first came to the Media Lab in the late 90s. And it's a burning challenge in the enterprise today because you and millions of customers like you send inquiries to companies every day across a wide range of digital channels. And these folks would love to be able to immediately get back to you and serve you better. What we really need to do is take your inquiry and put it into a format that we can just, essentially a database entry. And then what we can do is we can do analytics, and we can immediately reply. We can understand what you said. People are turning to machine learning and artificial intelligence to solve this problem, as we're seeing. But there is a problem. So today, the way this is done is you get a whole bunch of messages. So here's a whole bunch of customer messages, maybe millions of them. And then you send those off to human beings who you contract, and they essentially take, for each message, they take a multiple choice test. And they fill in what category does that message go into. And then what we do is we take those input messages and the results of the multiple choice test, and we use that as like a stimulus response. So you can think of it like Pavlovian conditioning. We use that to teach the machine learning to give the right response when we give it a particular kind of stimulus. But the problem is language is super complex. Even 15 words can express at least 10 billion different ideas. So that would be like having 10 billion columns on this multiple choice test. So clearly, we need a new idea when we think about how to teach machines how to understand language. So what would this be like? What would be the perfect artificial intelligence for understanding language in the future? Well, it'd be super accurate. It would understand everything that you say. And if it didn't understand you, if it was confused, then it would ask a question, and it would clarify, just like a person would. It would be easy for you to set up and teach it directly, and specifically to be able to control it. Like, even different than people, we'd love to be able to edit the ideas inside the system and be able to really design it to be the experience that we want. It would speak all languages, of course, and it would learn just by talking to you. It would learn just by reading the web. No supervised data, no multiple choice test. So Gamelan has built that. And we're set up to solve this problem. And at Gamelan, it starts with this thing we call an idea tree. Inside of our product that we're just announcing for the first time to you today. You're the first people to see this. And this is our Gamelan Idea Studio. And what you can do is you can say something like, my ATM card, my code is not working for it. So you can put in a customer message. And then the system says, oh, that's a debit card inquiry. And that has something to do with PIN numbers. And specifically, this person needs a new PIN number. And once those ideas are pulled out of that customer message by the idea tree, then we can output that to a database in structured form. And notice we used ATM, which is an abbreviation, and we said my code instead of my PIN number, so it was a synonym, and the grammar was kind of quite variant, and yet the system got it correct. In fact, we've benchmarked this against every leading academic machine learning natural language system on the planet and most of the big commercial APIs, and it's the most accurate natural language classification system on the planet today. But what's even more exciting is what it does when it's confused. So here's the state of the art if you want to order a pizza from Alexa.
Which pizza would you like? If you're not sure, you can also ask for the pizza menu.
Pizza menu.
You can order cheese, pepperoni, or meat lovers pizza. Would you like to
So
hear
menu,
more?
we hate menus.
You can order supreme or veggie lovers pizza. What would you like to order?
Sausage pizza.
Which pizza would you like? If you're not sure, you can also ask for the pizza.
You've probably had an experience like that. So let's order a pizza from Gamelan. So let's order a Brooklyn pizza with white sauce and onion. We could have listed all the options we wanted in a big long paragraph, and it picked it all out and immediately figured out in structured form just exactly what you wanted. And if you ordered the same pizza, a Brooklyn pizza with white sauce and onion for pickup, no, actually delivery, and you change your mind midstream.
Did you mean pickup or delivery?
The system knows exactly where it's confused, and it asks you a clarifying question just about that. Or let's order a crunchy pizza, which is something that both Domino's and Pizza Hut both sell. So it gets all the toppings right.
Did you mean Domino's or Pizza Hut?
It just asks you to clarify who you want to buy it from. So these idea trees are pretty cool. They're the most accurate natural language understanding on this planet. They go beyond classification. You can really dig in. And they ask clarifying questions when they need to. But where do they come from? How do we make these idea trees? So one answer is you can go into the Gamelan Idea Studio, and in a few minutes you can make one. So this one is booking and changing and canceling hotels, restaurants, and flights. That's all there is to it. This is a new kind of way of teaching a machine. No more multiple choice exams. This is a scaffolding that teaches the machine. There's a deep learning model behind it that learns from that tree. But if you don't even want to build a tree yourself, then another option is you can just pour in a lot of just stuff that the system could read. Why is it not advancing? There it goes. So I need to fly to Denver next week. I've got a flight tomorrow. I want to book a table at the Samovar. Could you change my room at the Four Seasons so I can have an ocean view? Just put in this big pile of sentences from the web or stuff that people have said to your company before. System thinks about it for a few minutes, and it puts out the exact same idea tree that we built by hand. Here it is thinking it through as it reads those utterances. And whether we build it by hand or build it automatically from just reading by itself or collaborate with the system and edit part of the tree while it edits part of the tree, we can still say, book me a flight to Denver, and it understands what we said. This is really a new world. And you can come in the morning and you can say, what did all my customers say to me over the last 24 hours? And the gray circles tell you where the trends are, every idea that's popping up. So for example, one of our customers is one of the world's largest automakers. They get literally tens of millions of customer messages a year. Just to process 100,000 used to take them months. 65% accuracy is what they got back from humans who were classifying them. They only got top-level categories. They couldn't ever change those top-level categories because they had to rewrite the explanations of all the columns, and then they would have to rerun all the training data, and they were paying more than $1 a message. Now with Gamelan, months have become milliseconds. We're over 95% accurate. They can drill deeply down into what's going on, find out about new issues that emerge in real time, and actually their total cost of ownership has improved by 5x. So we're working with many of the big tech players who you might imagine. We're working with the largest healthcare payer in the US, many of the largest automakers, some of the largest factory automation companies who get trouble tickets in about their engineering systems, and banks and all kinds of financial services companies. We're talking with millions of customers. We'd love to talk with you. Thanks.